Good day everyone, thank you for the opportunity to bring pyrometallurgical perspective into MetFest. Today I will try to talk about quite recent developments, all happening in 2025, which illustrate extremely well the situation in this field in Australia, but also relevant to Europe and Canada. Operating for more than 130 years, Nyrstar's Port Pirie is recognized as world's largest lead and zinc smelter. The operations in Port Pirie and Hobart are interrelated. They exchange materials to increase the recovery. Nyrstar's Port Pirie smelter serves as a core pillar of the local industrial base, contributing an estimated 1.7 billion in gross value added to the Australian economy and directly employing 1,400 Australians while supporting over 6,600 indirect jobs. The smelter's viability is threatened by a combination of global and domestic pressures. Economically, Nyrstar operates in a global market defined by intense competition and declining treatment charges, with the state-subsidized Chinese producers enjoying an advantage from integrated supply chains, lower power prices, low energy prices, and often less stringent environmental regulations. In parallel, the smelter faces rigorous environmental compliance requirements at home. Its new 5-year license from the mandates stepwise reductions in lead in air emissions. In 2025, Nyrstar has secured 135 million in what officials term as transitionary support from federal, South Australian and Tasmanian governments. But before we analyze this event, let's look at the recent history. In 2014-2017, the Nyrstar Port Pirie had costly upgrades, using both private funds and government support. They replaced most of the sintering with the smelting, using modern type of furnace. These investments were necessary to reduce the lead and sulfur dioxide pollution, and to create the opportunity for recycling of wide variety of materials. While SO2 emissions had an instant drop, the PB emissions were harder to tackle and required further investments in controlling fugitive dust from outdoor handling and storage of lead-bearing materials. Overall costs were about 660 million. In 2018-2020, lead and zinc experienced a 40% drop in price. All of that resulted in near bankruptcy of Nyrstar. A commodity producer, Trafigura, stepped in and saved it, but the original Belgian company, Nyrstar N.V., was left as a shell, holding only 2% and a mountain of debt. Its stock became worthless, and all other shareholders were wiped out. Let's step away from challenging and controversial topics on markets and corporate takeovers and focus on metallurgy. This is a simplified flowsheet of the lead and zinc process. The raw feed arrives on ships, trains, and trucks. It consists of concentrates from lead and zinc mines, fluxes and fuels, but also industrial recycled materials, including those from Hobart zinc operations. The inputs go primarily to the top-submerged lance furnace, TSL plant, where high-temperature oxidation reactions by air-oxygen mixture remove sulfur as a dioxide and create a molten slag. This process in TSL is highly exothermic and does not require much fuel. The gas is cleaned from the dust, which is recycled back, and clean gas is converted to sulfuric acid. I must mention that sulfuric acid is essential for most of hydrometallurgical leaching type of operations, as well as production of fertilizers. The gas cleaning also produces cadmium as a byproduct. Slag is then cast in molds to create high-strength blocks which are suitable for further processing in the lead blast furnace. The leaching residues from zinc operations in Hobart and other materials with high moisture content are baked in sintering machine to make them suitable for the blast furnace. The preferred option is to process all inputs in TSL, but quantity of those materials accumulated on site is quite large. so the TSL alone has not enough processing capacity. The blast furnace uses reduction chemical reactions to convert lead oxide into lead metal, while zinc remains in the slag. This process doesn't require coke as a source of energy and reductant. Coke is produced from coal. In theory, it is possible to replace this furnace with other type of furnaces relying more on coal and natural gas, reducing the overall CO2 emissions per kilogram of metal produced. But given the history of Nyrstar, I doubt anyone will step in to invest hundreds of millions more on replacing lead blast furnace with side-blown or bottom-blown reduction furnace. As it stands now, the ambition of Australian government to achieve net zero unilaterally is in direct contradiction with the existence of Nyrstar lead smelter and current efforts to use it for critical metal recovery. In more likely scenario, the plant will be disassembled and moved overseas. The town of Port Pirie will be no more. Metallic lead, also called lead bullion, accumulates impurities, many of which are valuable but still need to be removed. The Drossine furnace removes copper in the form of molten matte, which is a sulfide liquid forming a separate layer floating on top of lead bullion. Copper matte is skimmed and then processed into marketable product. After copper drossing, lead still contains most of gold and silver, which can be separated using the process invented by Alexander Parkes in England in 1850. Also, the blast furnace slag can be further reduced with the production of zinc fume, shipped to Hobart and turned into marketable product there. Other impurities concentrating in lead bullion are arsenic, antimony, tin and bismuth. They are already being removed from lead, but not refined into individual metals to make a marketable product. Also, a portion of indium, another hyped critical metal, can be potentially recovered through zinc fuming process. The primary objective of the latest funding package is to fast-track feasibility studies and asset upgrades with an immediate focus on deploying an antimony pilot plant in Port Pirie. The successful commissioning of this pilot plant would make Nyrstar Australia's only producer of antimony metal and one of the few globally. The initial step is the so-called Harris process, which uses oxidation of arsenic, antimony and tin from lead into molten sodium hydroxide as a solvent and sodium nitrate as an oxidizing agent. This process already works and produces what is shown as a byproduct of lead refinery plant. Further steps rely on hydro and electrometallurgy, sulfide leaching, fractional crystallization, and electrowinning. Both antimony and arsenic leach into hot liquid, leaving solid lead and tin oxides behind. Solids are recycled back to TSL. Large portion of thioantimonate will selectively precipitate upon cooling, since the solubility of thioarsenate is higher in cool water. The crystallized product can be redissolved and turned into pure metal by electrowinning. The liquid still contains some dissolved thioantimonate, so it can be oxidized into even less soluble product, but this is optional. The overall concept is not new, it has been realized in other places, so I am optimistic the antimony plant will work. But why has antimony become so important in 2025? Antimony is a critical mineral vital for global defense and technology, used to harden lead in ammunition, but also used in night vision systems and in nuclear weapons. In terms of volume, a lot of antimony is now consumed for low light absorption glass for solar panels. But massive AI data centers also need a lot because of flame retardants in printed circuit boards. Thus, economically, it is also of high importance. It is this dual purpose of antimony that makes countries like US very nervous. But importance alone is not enough for a metal to be considered critical. We also need to look on the risk of supply, often linked to the degree of monopolization. The global supply of antimony is highly concentrated, making the market susceptible to geopolitical risks. China dominates global production, accounting for over 40% of the world's mine output. Russia, Tajikistan, and Bolivia hold the majority of the world's remaining reserves. But it is refining of antimony which is really monopolized, up to 90%. If your country mines the antimony but does not refine it, essentially the access to it is still at risk. This concentrated supply base has created a significant vulnerability for Western nations. Recent Chinese export restrictions on antimony ore and related product slashed shipment by 97%. Between 2024 and 2025, the price of antimony increased by 400%. This strategic move by China, aimed at retaining value-added manufacturing within its borders, has heightened concerns about supply chain security. In response, the U.S. Department of Defense, recently renamed to the Department of War, classified antimony as a Tier 1 critical mineral and has allocated significant funds, around $1 billion, to stockpile antimony and motivate domestic production. The case for producing antimony is therefore driven less by traditional market economics and more by a profound geopolitical imperative. Furthermore, the rich resources of antimony mined in Australia are also associated with gold, which also becomes strategic for monetary stability. As we saw, Nyrstar's lead-zinc operation is suitable to recover precious metals as well. The question is, if Nyrstar demonstrates the ability to recover antimony, will it get access to those lucrative gold antimony concentrates? Based on my research together with Google Gemini, the perspective is extremely low in near future. Hillgrove Mine, belonging to Lavroto Resource, signed a binding 7-year offtake agreement for 100% of antimony gold concentrate to Vaughan Resources, a global metals trading firm. Costerfield Mine, owned by Mandalay Resources, has a long-standing offtake agreement with the Zhongnan Antimony and Tungsten Trading Company, a Chinese smelter. Nyrstar is building a facility to process exactly this type of material, but its two most obvious domestic suppliers have already been forced to sell their products to overseas buyers. Costerfield's concentrate goes to China, and Hillsgrove concentrate is contractually bound to a global trader for the next 7 years. Also, I don't have inside information. It seems Nyrstar's new antimony plant will rely on accumulated internal recyclables, at least in the near future. Another case is the Orient Project in North Queensland. The project, which Iltani Resources has confirmed is Australia's largest and highest grade known silver-indium deposit, is de facto a lead-zinc deposit. Again, if it is mined and processed into concentrate in Australia, but then shipped overseas for refining, then we can say that it is in line with the critical mineral strategy, which aspiring to more processing and refining minerals onshore in Australia. Over the years, our research group had many projects to help Nyrstar, particularly to optimize the operations of newly installed TSL furnace. As I mentioned before, the furnace is designed to produce molten slag. In the beginning, the focus was on the achievement of design productivity, and the recommended slag temperature was about 1250 degrees Celsius, ensuring it is fully molten, low viscosity, and dissolves feed materials very fast. But in discussions, it was understood that this high operating temperature is not sustainable in the long run because it results in increased hot corrosion of furnace lining made of refractory ceramic materials. In smelting operations, the fast loss of refractories is the major financial risk because the repairs require full stopping and relining, which is a huge operational loss. Thus, we collaborated with Nyrstar to do an advanced plant sample analysis and phase equilibrium modeling to justify the small changes in fluxing, ultimately resulting in decreased temperature of operations to 1180 degrees. This extended the working life of the refractories. Other projects related to hot corrosion included the selection of steel for lances delivering air-oxygen blast into smelting furnace, and understanding the degradation of steel walls in the blast furnace. The latter was identified as an unusual arsenic-induced mechanism. Other examples of UQ's collaboration with industry are education, training, and advice. Here we can see UQ's graduate Kun Su, who recently has appointed to a position of plant metallurgist. Latest discussions were quite interesting. After more than 5 years of operation, the major rebricking of the TSL furnace was finally due. For that, the operation must be stopped, and large quantities of slag must be safely skimmed. There were some ideas how to reduce the lead emissions by vapors during this operation. We helped to do the advanced thermodynamic modeling and verify different strategies. I was notified last week that the operation was successful. My point is, it is not only regional jobs that are under threat, but the expertise in high temperature chemistry in the country. Smelters close not only in Australia, but in Europe and in Canada. The funding of metallurgy programs dries away, and there will be no longer experts in the universities to revive those processes when the need comes. Already now, we train newly hired process engineers in top 3 of Europe's recyclers in pyrometallurgy, because Europe's university departments do not teach this course. As a conclusion, Nyrstar is in very good position to process concentrates containing antimony. If this happens, Australia can become an alternative to China, balancing somewhat the monopolized market. The world's economy now does not operate according to the rules of free market, which is unfortunate. In the foreseeable future, more bailouts like those provided to Whyalla Steelworks, Nyrstar, and most recent one is in Mount Isa will be needed. I don't have the inside information and could not find anything in public domain, but it seems the plan for Nyrstar in the next couple of years is to process antimony containing internal recycling streams that are already on site. As for 2 major existing antimony mines, they both are committed to sell overseas, one of them definitely to China. This approach, of course, does not contribute to securing access to Australia's critical minerals. The status quo of Australia being a simple exporter of raw materials will lead to further shallowing of economic complexity. Of course, Nyrstar may try to go further on the path of recycling, increasing the quantities of lead-acid batteries, electronic waste, and may have a chance to process Orient Project concentrates. This increases complexity of the operations, likely requiring further investment in equipment and in R&D. Finally, I would like to address the elephant in the room. If Australia insists on achieving net zero by 2050, there is no way Nyrstar can comply with those regulations. The parent company Trafigura will simply shut it down and process the concentrates elsewhere, adding CO2 due to shipping of thousands of tons of materials across the ocean. The green hydrogen does not exist. Thank you for your attention. I would like to thank Professor Geoffrey Brooks for discussions and introductory lecture Antimony, the Forgotten Metal, and I would like to thank the industrial sponsors and governments of Australia and USA for supporting our fundamental research on phase equilibrium and thermodynamics of metals, including antimony.